In order to be able to use IC functions for the legs, it's needed to call a special function and make a setup. This should be done in the Begin Play menu. Let's start with choosing the option for humanoids. Let's set the parameters for the leg's bone name. Please note that you need to choose foot bones exactly. Now we have to set up sockets. They are needed so that the algorithm could correctly rotate the foot along the surface normal. One socket should be on the front edge of the foot, the other, on the back edge. Use Alt plus Move to copy the socket. The location of sockets is important for the algorithm. Don't locate them near the very edge of the foot. In order to set up the forward vector for the legs, we need to understand to where the knee is oriented. Apparently the knee is oriented exactly along the y-axis. The phrase "to where the knee is oriented" can be reformulated as "to where the leg straightens out." The rest is still the default. The update rate is needed for optimization of a number of frames needed to carry out the calculation. Prediction mode. The algorithm tries to carry out the calculation only when the character puts its feet on the ground. The range can be adjusted using a coefficient, where 0 is when the legs are strictly on the ground, 1 is when the legs can be raised to pelvis bone level. Otherwise, the calculation will be carried out regardless of the location of the legs. This may cause unwanted movement of the body. Foot angle clamp is the limit for turning the foot, and here we are talking about turning when the toe goes up. This turn is not quite physiological for the human foot, so it's better to limit it. But if we limit the rotation, then we have to raise the leg, otherwise the leg will fail in the textures. For this, there is an UPCOF parameter. Ground delta z is needed to make an offset for all legs with regard to z, it used to raise or lower a character. It's also possible to adjust the height of the trace down and up. Anchor size is a parameter for stabilizing the foot. The more it is, the more stable it is, but the heavier the foot is. It's also possible to set the transition time, as well as the coefficient for this time during movement. Max lift legs is the parameter that determines the maximum lift for the leg. It is needed so that the legs do not go up much. It's also possible to set the maximum leg length, set here less than 1. The maximum leg lift can be readjusted for a specific animation. Let's now consider a similar function for animals. There are two options for the function. Let's start with selecting the simple option. In this case, we need to set up 2 pairs of legs. Let's set the bone name parameters. x offset is needed here to shift the point for calculating the leg. Notice that the forward vector for the front legs is pointing towards y. This is all because the front legs straighten out back, their joint is turned in the opposite direction. Don't make a mistake, otherwise the algorithm won't work correctly. Low body mode is the mode when the legs are too short or turned in such a way that the body will be almost at the ground, for example, like by the spider. Also, if legs could be turned off at all, leaving only a back turn. It's sometimes necessary for optimization. The last parameter is needed for the correct processing of stairs. It's only experimental for now. Root bone name. Leave none here, the 0 root bone will be automatically selected. Now I'll show the not simple option. It differs only in that it's possible to set sockets as for humanoids to turn the foot. Let's now consider the version for spiders. It's possible to set any number of pairs of legs, but the greater it is, the more effect it has on the performance. I'll set for 3 pairs of legs. Let's now start with setting up the bone name parameters. Note that the spider has a lot of bones in the leg, and the algorithm uses only 2 bones, so if you have a lot of them, it's possible to choose a suitable pair. Play around. Regarding the forward vector, note that the knee of a spider, to where the legs straighten out, is mostly oriented upwards. Therefore, the Z component is so large. The front legs also look slightly forward and to the sides. The middle ones, to the sides. And the back ones, backwards and to the sides. Please note that the low body mode is enabled here, because spider's body is almost at the ground. It's also possible to turn off the IC legs here, and to make a calculation only with regard to the front to back subspace. When turning sideways there will be no calculation. These options are mostly needed for optimization. Use root trace as an additional parameter needed for a more precise calculation of the body position. Now I will show how it works. It can be seen that the body is lifted only when the lift was carried out. Otherwise, the movement of the body will be simply as an interpolation according to the positions of the legs. For this type of trace, it's possible to customize personal frame rate and alpha. There's also a version of this function that uses a socket. It's needed for a more precise definition of the location of the spider's limb. I'll show now the special function that allows compressing all the traces from the legs to the body. This is necessary if the spider is overcoming a narrow obstacle, for example. In this case, the legs will hang down and the calculation will be incorrect. It's possible to adjust the speed, as well as the offset. It's needed to make sure that we are really on a narrow surface and stay on it for at least half a second. There is a special version for worms and similar creatures, which have no legs. This is the easiest type of calculation, which uses 4 sockets to understand how to rotate the body and to make it parallel to the surface. Sockets can be created from any bone. It is very important, if the worm is large enough, the height of traces should be increased, otherwise they will simply not reach the surface. It should also be noted that a capsule for such creatures should be more subtle, otherwise the calculation may not be correct. Idle processing. This function disables the calculation when the character stands without movement. It's needed for optimization, disabled by default. It's also possible to set alpha. Additionally, it's possible to set the height of the traces. Some of them need to be changed, for example, when moving in specific conditions. It's possible to change the version of the algorithm. There is only 0 or 1 for now. It's possible to disable the EEC algorithm for a separate pair of legs.